Hello and welcome to this Burning Earth tutorial on Earth Nullschool. This is your host, Gerard Spring, coming to you from North. So I want to take some time to develop a tutorial on Earth Nullschool and have a look around at some of its features and try to explain some of the things that are going on when we're looking at the climate system. You know, there's a lot of information in Earth Nullschool, and you can click around and learn a lot by just checking it all the time. So when you first fire it up, you get this really nice view of Africa here, and you get some nice wind patterns. You know, you can see, click around, and you can spin around, explore. You know, you got Sri Lanka here. You know, you have Thailand. You know, a lot of things you can do. You can get a sense for what's going on. Kamchatka here. Say, for example, over here in the Pacific Basin, you know, we have these cyclones. And when you click here, you can see what the direction of the wind is, where it's coming from, and how strong it is. And you also have, you know, the latitude here and the longitude here. So this is sort of the intro screen to Earth Nullschool, and you can see what's happening. So if you come over here and click on this panel, you get this nice menu that allows you to change the view and change the settings and look at different data. So of course we have the date, you know, which data we're looking at, the scale here, you know, where the data is coming from, and a nice control panel. So if you step back, you can actually step back a few days and see what's happening. You can see how things evolve, for example. Say, for example, we look at this cyclone here, you know, or we step forward in time, you can see that the cyclone is moving. One more day here. And you can even step forward in time, actually. And these are projected models of what the supercomputers essentially think is going to happen. I think you can go 3 or 4 days forward. And now you have now as well, so you can just flip back to now, or the most recent data set. So I want to spend some time looking over here and looking at the different modes. In particular, for this series or for this video, I'm going to focus on the air and some of the height features and looking at, you know, wind and temperature and trying to explain what's happening with those. So if we look here, we have the air, and right now we're looking at wind patterns. So we can swing around and look at various wind patterns. And you can see over here we have this height selector here. And on the overlay selector, we have wind. We can change these things and look at different things. But I want to focus on this height selector here because it's pretty important, because it's also a little bit difficult to interpret. So you notice over here that we have this funny HPA. And what this stands for is hectopascals. And hecta is just a fancy prefix for the meaning of 100, basically. So this is in units of 100 pascals. So, you know, here we have 1,000, 7,000, etc. And why this is a height is as you go up in the atmosphere, the pressure decreases. So it's often common in climate science and atmospheric science to talk about height in terms of these pressures. And in order to explain this, I made this nice table for you guys so you can see, you know, you have the pressure right here, you have height, the temperature in degrees C, and then sort of what's happening at that pressure. You know, here at the surface, it's kind of nice and warm. You know, above the surface, maybe it's a little bit colder. You know, here at 700 hectopascals, 3,000 meters, water freezes. You go up a bit further to 50, you know, you have the jet stream at, you know, 10,000 meters, about where planes fly. And then if you go up even further, you have the stratosphere. So you have different things here. And these numbers aren't exact. They're approximate. They're rounded. So it's just to give you a general feeling of what's happening at different layers in the atmosphere. So swinging back over here to Earth Nullschool, we can take a look at what's happening with the wind patterns at different levels in the atmosphere, you know, in a given place. You know, for example, here, you know, we have some kind of things happening at the surface. Or if we swing down here, maybe in Patagonia, for example, Antarctic Peninsula, you know, you can see we have a nice cyclone developing here. You know, as we step up in the atmosphere, for example, we can see that the winds are getting a little bit stronger. You know, we can maybe swing over here up into Brazil area, you know, Argentina coast here. We can see that we have even stronger winds over here. You know, we can step up to where water freezes at. You can see that there's a lot more jet stream type structures developing, faster winds, you know, circumpolar winds. taking a look at the jet stream itself up at 250, we can see a lot of jet stream structures. And, this is precisely the kinds of things we're going to see with abrupt climate change, folks, is we're going to see this mixing of the two jets. And you can get it right here in the tutorial series just by, going through and taking a look at Earth Nullschool. You can see this nice crossing of the jet stream here, coming in over Namibia and then crossing back up, this time through the Congo. Whereas last time, that recrossing, was coming back up maybe a little bit further to the east. So coming back to the surface, I think it's also interesting to look at the temperatures. And what this is this is the temperature at the surface. So if you were standing on the surface, this is the temperature that you would feel. For example, if you were in the UK here, maybe down here by, Brighton or Southampton, 6.1 degrees C, over here, Gibraltar, 12.2 degrees C. Over here in Egypt, it's nice and warm, 17.3 degrees C. You kind of explore around, Sri Lanka, again, 23.6 degrees C. You can also check about the temperature just above the atmosphere. And, for example, up here in Turkey at the surface, you have minus 2.1 degrees C, for example. But if you step up in the atmosphere, you can see it gets actually warmer. Even though the pressure goes down, it gets warmer. So you can see these kinds of structures looking through the atmosphere. And, for example, over here in Iran area, you have a lot temperature, 28.3 degrees C just above the surface. And then, at the surface, it's 11.8. We can also look a little bit higher up in the atmosphere, maybe, for example, where water freezes at. If we zoom out, we can get a general sense of what's going on. You have a lot of this area in equatorial regions. The water doesn't freeze yet at 700, but up here in the Arctic and areas and subarctic, and even down here in the Mediterranean basin, you have some water that's freezing up here, whereas down here it's still liquid or vapor phase. You can step up even further into the jet stream. You can see it's very cold up in the jet stream. You can also get a picture of the winds and where the warmer areas in the jet stream, where the colder areas in the jet stream are, 48 below here, off the coast of Africa. So I think it's also useful to swing back and look at the total precipitable water. And what the total precipitable water is it's the total amount of water that can be rained out of the atmosphere. And if we're looking at warm air coming up from the south, for example, you can see that, the warm air tends to hold more water as it gets pulled up into the north. So if we click on this jet, for example, that's, coming out of the Caribbean, we can look over here and we see this kind of funny number, this 51.598 kilograms per meter squared. And what this is that for every square meter of land, or in this case water, there's 51.598 kilograms of rain that can be rained over that spot. So for the square meter that you're standing on, there's 51 kilos of rain above you, or since 1 kilo of water is also 1 liter of water, there's 51 liters of rain above you for the square meter that you're standing on. And you can see here down in this Caribbean jet coming up, these numbers are very high. But if you swing up here, for example, into the Canadian Arctic, where, it's very cold, this number is very low. You have this 2.566 kilograms per meter squared. So this is due to the fact that warm air tends to hold more water than cold air. And this is a basic fact that, it's useful to remember maybe from chemistry or physics to hang on to that fact. It's also nice to look at relative humidity, for example. And if we swing over here to relative humidity, you can see that, a much different pattern develops. For example, areas that now have very high relative humidity had very low total precipitable water. And this again reflects the fact that warm air holds more water in it than cold air. But this air up here, even though it's cold, is more saturated. So it's holding more water of its total amount that it can hold. So I hope you found this useful, folks. And if you like this first step in the tutorial series on Earth Nullschool, please comment, like, and subscribe. It was a pleasure having you along, and I'm looking forward to having you along for the second part.